Um, okay, that seems to be recorded. I didn't hear the message I usually hear, but I assume that started. Okay, well, welcome everyone. It's the first time I've been here. Well, I've been here for a while for AI Sandbox. It's interesting to be here. For those who don't know me, my name's Stephen Whittinstall. I set up or founded the archive work group a couple of years ago, and which is now been predominantly taken up with Vanny and Andre in developing a system where we can record the history of the ambassadors program. And I'm sure many of you use the dashboard to record information about your meetings. So what I'm here today to talk about is a development on that, which is we record all our data on a database that Andre has developed using JavaScript and stuff, and we dump a lot of that data on a regular basis in JSON format, which is a format, yeah, an open format which can be reused. And we're going to take that a step forward now by taking the JSON data and converting it to graph data. And that's what I'm going to talk about today. I've done a little presentation. I'll start with that now. I'll try and share my screen for that. Hold on a sec. Okay. Can anyone see that? Say yay or nay.
Yep.
Yeah, you can see that. Okay, I'll start a slideshow. Okay, so what I'm going to talk about today predominantly, and I'm going to try and do a little bit of some demonstrations as well, so bear with me, is how to convert archive JSON to graph data. So first of all, what is graph data? Well, graph data is comprised of nodes and edges, and there's a little diagram there. So a node is like something that's an entity. It could be like a person, a meeting, or a document. And an edge is a relationship, is something that connects two nodes together. So it describes how they're related. So an example here is, a node that is me, and then a meeting, and then the edge is hosted by. So this meeting was hosted by that, that creates a representation, a graph representation of data. Uh, so why JSON to graph?
Stephen,
JSON.
we're not seeing the slides advancing. We're just seeing the first one. I don't know if they're meant to.
Okay, okay, let's stop share again. Let's try that again. Oh, let's try this one. Okay, that's weird. Hold on a sec. Okay, can you see that?
Yeah, maybe if you go to slideshow so that we can see it full screen because it's kind of small.
I did. I tried that, but that's when you can you see that?
I can.
Okay, right. So that's nodes and edges. Is number one nodes and edges. Can people see that slide? Yeah.
Yeah.
Okay. So why Jason? This is slide two. Can you see slide two now?
No, we're still seeing what are nodes and edges.
That's annoying. Let's try again. Can you see this?
Yeah.
Okay. Well, I'm going to stay here because when I go to shared, so it seems to be not showing the slide. Um, okay, so JSON is why do we have JSON in the first place, and what is the nature of the JSON we have? The data we record from the archive is recorded in a traditional SQL database, and when data is exported from there, it is exported in a nested format. So it's a fixed structure, which is like a tree. And a graph, in contrast, is more like a network rather than a tree. So in a graph, each object in a tree or each object in a list becomes a node, and then as the structure goes to the side, then you can infer what becomes an edge or relation. So the way you decompose JSONs into graph is that you identify entities or nodes, and you might to do that you look for things like nouns or objects. So things like work groups, meetings, people like hosts, documenters, documents is another entity, agenda items, and things like tags even could be entities. And how you identify relationships, you look for the verb or connection. So a meeting belongs to a work group, a meeting is hosted by a person, etc. So, example transformation. So this JSON fragment here, which is a hierarchical structure, you can see at the top it's meeting info, and then
We're not seeing your screen anymore, I don't think. Is anybody? Oh, right, sorry. Beg your pardon.
okay. And sorry. So the graph version of that is broken down into uh, the entities, which are a meeting, and people, the people who are included in that fragment. So Stephen and Callie. And the edges are, oh, hold on a sec. Sorry. Just going to try and move this. Yeah. Yeah. So the edges are a meeting is hosted by and a meeting is documented by. And I've got some other examples, but maybe if I move on a bit, because these are different, there are just different examples of how what's a JSON fragment and what's a graph version of that. And here's trying to be a visual analogy of that. So JSON has a nested outline. I'm sort of apologize for people who already know this. So it's like at the top level meeting and then a sub or host, and then, for example, agenda underneath that is action item. But in a graph, rather than being a nested outline, it becomes connected bubbles like a network. And that's a representation there. So it becomes, I'll demonstrate this more graphically soon, but it becomes like a map or a network. Okay, so how are we converting JSON to graph? So we're doing this using Python, and the reason why I'm using Python is because it's open source, a lot of the libraries I'm using, and it's very portable and transferable. So the code here, I'll try and share as well in chat at the end. First of all, we download the meeting summary JSON from a URL, and that's stored in this repository here, which is in our Singularity Net Archive repository, and that's downloaded on a regular basis using a GitHub automation. So it takes the data from archives and dumps it in a big record of JSON. So that's where we're getting the data from. I don't know, where's the slide gone? Hold on a second, let's try that again. Seems to have lost the presentation again. Okay, let's go to slides. Right, and then after we download that JSON data, we 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 extract nested fields. So we extract all the JSON entities, so the workgroup meetings, and we take that data and we convert it into something called a dictionary format, which is a standard data format or data frame, as it's called for Python. once it's in that dictionary, that allows us to manipulate the data. And we then convert each entity using the logic that I've described before into a node. And then we also carry along with that, assign attributes to it. So, for example, if I am a node, one attribute of me could be my first name, another attribute could be my surname, for example, or an attribute of a meeting could be monthly or weekly, that kind of thing. And then you create the code creates directed edges. So it sees what nodes have relationships to other nodes and then creates edges from that. So for example, has a meeting or hosted by or tagged by. And that code is then that creates a I've got the code here documented in our repository, but that's a nodes and edges. Okay, so let's I've got this moved over here. Another thing that can create a JSON file of nodes and edges, but also it can create other XML format or to import into graph analysis tools. And a very prominent graph analysis tool is called Gphy. And I've got a web link there. I'll try and share this presentation at some point. And I wrote another piece of code which converts the JSON file to an XML file. And the XML file is again a representation of nodes and edges, but in a way that can be imported into Gphy. Let's try and go. Okay, and I'll try and show this live. Okay, so what I'm going to do with Gphy is take a file that has been converted from JSON and converted into nodes and edges and then converted into an XML file and then imported into Gphy. And then I'm going to format that graph and apply some logarithms to try and see patterns in the data. Okay, so I'll bear with me. I'll try and get this up. Okay. Yeah. Okay. So I'm doing this from scratch. So it opens. Okay. Can you see that, everyone? Can you see that Gphy has loaded?
We're still looking at your slide.
Oh, God.
Yeah, same for me.
Blah, 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 blah. Let me try and. Okay. How about now?
Yeah, it's just loading. But yeah.
Okay. So this is Gphy, which is it's used a lot in academic research. It's a kind of a standard tool for doing graph analysis on data. And this is where you come from. There's a default screen, so you can import data here. This is welcome. So in this case, hopefully this will work. I think I've got a file which downloads all the archive data from 2025. So this is, I've now selected that file, which is an XML file, which I created from Python code. And in that file, that file is a directed graph. A directed graph is all that means is that a node is directed to another node, or it's directed. So, for example, a work group has a meeting that's directed to that, or a person attends a certain work group meeting. That's a direction there. And here is enumerated the number of nodes. In this case, is about 1,800 roughly nodes and about 3,500 edges. So I'll just open that, and that's the default view, which is a bit of a dense mess because we haven't formatted yet. But that's the raw data, which is like thousands of or hundreds of nodes and a few thousand edges. Okay, so first thing we may do is look at how the graph is partitioned, and we will choose, no, sorry, not ranked, how the graph is ranked. So we're gonna look at it in terms of the degree. So you could take a graph and you could format it in terms of in degrees and out degrees, like what are the number of connections a node has outwards and what are the number of connections into a node. But the for the sake of clarity, we're just going to do both. So we're going to look at both. We just want to see what level of degrees are going in and out through all nodes to other nodes, and then we apply that, and that gives you a kind of concentration map, or a where some nodes, where the nodes that have more connections are darker, like for example this one, than nodes that have less connections. So if there's that they'd be lighter. Okay, so that's still very dense. It's still very difficult to see what's going on. So what we want to do now is to try and identify communities or clusters in the data. Um, so there are some standard algorithms which we apply to look at, they're called force-directed algorithms. So what they do, they detect clusters of data and then will apply a kind of gravitational pull to that, which will pull different nodes towards different centers. So I'll try and run one now. And the first one I'll run is a standard one called I'll try and pronounce this, the Fuchter-Reingold layout, which is a force-directed algorithm. So if I run this, and this is in real time, so it will take the data and to start to detect patterns in the data, and then try and group associated nodes together in clusters. Um, so this may be as you can see, it takes a while. What is quite process intensive because it's looking at hundreds of different nodes and hundreds of different edges, and to see which are associated with which ones. And as you can see, we can start to discern certain clusters or indications of clusters, but it's still not very clear what's going on. So we can continue running this if we had a very large data set. We could continue running it, so it actually could run for a few minutes even. And as you can see, if you select a different node, you can see the really different relationships or edges that come in from a particular node. So we're going to stop this one for now because that's just a demonstration of what a force-directed algorithm looks like. But we're going to use a more sophisticated one called Force Atlas 2. And what we're going to try and do here is to further disambiguate or to try and identify clusters in the data. So the scaling for this needs to be 50, and I need to prevent the overlap of nodes. So I want to try and prevent the overlap of these different edges, so it's less of a noise and it becomes clearer to what's going on. So let's try this algorithm. And this may take a while to come up. Try and zoom out actually. Oh, yeah, I've zoomed out, but that's not very. Let's try and zoom in a bit. There you go. Oh, let's try and this is live. I'm sorry. Just trying to figure out how to zoom in. um, let's try this. Right, here we go. So this is like from all the data, and as you can see, the logarithm is trying to identify different clusters, and you can see these different outliers and clusters um, emerging in the data. A cluster can also be called a community. So a cluster is basically knows that cluster around something that has something in common with that. So one obvious candidate for that could be a work group. So these clusters could be work groups. Now, to further there are also in GPhi a whole set of statistical methods you could run here on the right-hand side, like network overview. But we want to run a test of community detection. So what we're going to run is run a statistical analysis on modularity, which is to see, to try and ascertain the number of communities. What are the top level number of communities? So I'm going to run this logarithm here, and this comes up with this dialog box, and I run this. And this is telling me that there are around 18 to 19 different communities, and that could correspond to numbers of work groups. So I've run that analysis, and that's stored in memory. And then let's hopefully then I can hopefully take the graph and then try and partition it into different clusters. So what I'm going to do here is go to partition dialog. I've already choose the statistical analysis that I ran, which was a modularity class. And this gives me the modularity groupings by color. And then so you can also see the percentages here. So some communities are larger than others. So for example, community 13 represents 13% roughly of all the data. So I've applied that, and then you can start to see more clearly the different communities. So, and these probably relate to work groups. Okay. So over here you can see, for example, that's probably the governance work group. So you can see each of these is probably a meeting that's related and created a community cluster. But also you can see its relationships with other community clusters. Um, the other thing you can do is you can apply labels to the nodes. Oh. And if you apply the labels by default, you get a very messy because you can't really see what's going on. But you can, I think if you do that and you reduce the font size, see, you might get a better idea of different nodes in here, so we see what's going on a bit more. I'll try and so this node here is see this one here. So you can see here the different entities that are in the graph. Okay, so that's that. That's just a demonstration of the beginning of how you would look for patterns in the data. Okay, and then also all the data that's been imported can also be viewed in a flat file format in the data laboratory section of GPhi here. And you can manipulate this data a bit like a spreadsheet and run queries on it and things like that. So you could say, for example, which work group has the most activity or something, or you could also apply time constraints. So you could say filter all the data between a certain time range. That's another thing you could do, that kind of thing. Okay, so that and all, then so you, that would so you would do analysis, and the reason why you would do this analysis is to see factors like the influence of certain work groups, the influence of certain attributes, or like tags and that kind of thing. Okay, that's that. Let's see if I got the JSON graph again here. Okay, so the analysis you do, and that's kind of the stage where we are at in the archive work group. We're kind of beginning to do analysis of um, statistical analysis of graphs um, from work group data. Um, I'm just going forward a bit. Why are we doing this? So we're doing it to identify and compute metrics from the data. So this is the next thing we'll do. And so we'll be looking at things like centrality, which are things like which node has the most influence, that kind of thing, or um, and what communities are there. And also we could do this from different perspectives. For example, looking at tags, so we could say, which is the most central tag? What's the most influential tag, if you like? Or we could look at people and see how people have interacted with different work groups, in what way they've interacted with different work groups, that kind of thing. So this is the stage we're at the present. So we will do that. We'll do analysis, and then um, we can then capture that analysis and reconvert it back into JSON, into a JSON format. And the reason why we would do that would be to create the basis for is to create a context that we agree on, so, which then can go back into a generative model. So we would take the additional information that we have from Gphy, import it back and add it to our JSON format, the nodes and edges that we have in JSON. Now, I think I've got an example here of what that might look like. It's quite a small. So how would the JSON be enriched? We would add summaries and embeddings and key attributes to each node and edge. So I'll try and maybe try and zoom into this a bit. So, for example, if we have a node like a work group label, like the governance work group, the analysis that we do in Gphy could provide further information about metrics. For example, the degree of connections it has. In this case, it's null, but we would update this to the number of connections. The influence it has, that's the page rank algorithm, which we'd add in there, and things like betweenness, like for example, if it does this work group act as an intermediary between one work group and another, that's one for example. And then we can have information about neighbors. So what surrounds this node, and then a community summary. Then we can then create embeddings for that, which then can go into a generative model. So let me just try and, okay. So again, we're not at this stage yet, but this is what we're planning to do. Once we've done that, we will have a format, an enriched JSON format, which will be ready for vector retrieval. So be ready to be chunked into bits for a generative model. But the reason we're doing it this way is so that we are enforcing our own strict context. And this is so the generative model cannot hallucinate, it cannot really lie, because it can only answer according to the context that we're giving it. So we would give it placeholders like we would say that this work group has this number of connections, and that's it. You can't really say anything more than that. You have to use that data. Once that's created, you create this data here, and you create an array by generating vectors from node profiles. Okay, so that's our plan. The stage we're at is the GP stage, which is the analysis. So we're doing core analysis of centrality and community influence. Okay, so that's and just on a last thing on this, we've also done a proof of concept to see how this is all using standard graph analysis, and which academics use a lot, and also with the aim of chunking it up into a generative model. But another way the data could be used, another approach is to use the meta language, which I've done a proof of concept of, which if we went down this route, what we would do, we would convert the JSON into nodes and edges, but in a format that Meta would accept. And this Meta is basically is slightly more sophisticated. I've only just begin to scratch the surface of that. It not only creates graphs, it also will keep the graphs in memory as a knowledge base. So it'll create a kind of intelligence or knowledge base that it can be queried. It also uses slightly different language. It uses the language of atoms rather than nodes, and but it can still be used to visualize data. So the here's some scripts I wrote. That's the script for converting JSON to nodes and edges. So that's code. This is the script that creates an XML file, or this is the XML file that's created for Gphy. So it just creates nodes and edges from, for example, the node, this archives work group creates these nodes, and then it creates the edges from it as well. And then for Meta, this repo, I created this repo a few days ago to demonstrate how you would create JSON for input into the atom space. So there's the oh, sorry, that's not very. So there's the code for that, and again, that imports. This could be importing graph data or JSON data from our archive, and then it just uses the API for Meta. In this case, it's built in. It's converting graph, or in this case, JSON tuples to Meta atoms, which could then be queried. Okay, so sorry if that's a bit of a brain dump, and apologies for the poor presentation. Now I can share the presentation if people like. And have you got any questions and or anything people would like to clarify?
Hey, Stephen.
Yeah,
In Mindplex, we did have a talk about this whole thing, having the vector modeling. Um, we were taking some things out of this SAS tool. I can extension and show you guys. So,
a SAS
yeah.
tool. Okay.
Yeah, as a SAS tool and all. It's not publicly available. But it's
Right.
not open source thing.
Right.
Yeah, the sort of like the representation you must be getting, like, given for example, must be like this, right?
Yeah.
Like, yeah. So, yeah. So I had this in my mind, and I approached some guys, SIOs of SingularityNet, and we had this in our plan to have the SEO data and generate some sort of like a summaries,
Right.
and
So
yeah,
that,
for the Mindplex magazine itself. And yeah, so I was already working upon it. Yeah, we were looking to in the end getting to the atom spaces and all,
yeah.
getting with the whole foundation model
Yeah.
itself. But yeah, yeah, that's a fantastic idea we've been working for. Great
Yeah.
idea.
Yeah. That's great. I mean,
Yeah.
the oh, trying to see what I'm doing here. Hold on a second. Oh, sorry, my screen's gone a bit funny here. Yeah, the I'll have a look at that actually. Is that a paid tool, proprietary tool?
Yeah, as a paid
Yeah,
tool.
yeah,
Yeah.
yeah. That's great, and it looks like it's doing the same sort of thing as, say, something like
Yeah,
Gphy. Yeah. Why I'm
yeah.
what again my focus, even though it can be a bit slow, is that the archive works group is very takes an open source approach. So we
Yeah.
everything I'm writing, I'm trying to write in such a way that people can reuse and also potentially use as educational materials. So
Uh-huh.
certainly you could, there's lots of different graph tools out there. For example, another one I have used is something called Neo4j, which is another one
Yeah.
which
Yeah.
uses the sci-fi language. But again,
Yeah. Yeah.
that is quite has a cost associated with it.
Uh-huh.
I will have a look at Infranodus and see what it offers
Okay.
because that could be a
Yeah,
more
it's a full-on tool.
it's a yeah,
Basically, at the last of we had, we were looking to use Neo4j.
right,
It's been used by Nina too. One of our depends we have. So yeah, Neo4j is a really reliable tool. People have been working upon as an old tool now for the
right,
vector modeling and all. So
yeah,
yeah, we were looking to use this Neo4j.
right,
But this Neo Infranodus is just sort of like an example we were looking to work upon, where is basically we had a plan to have a ASI Edu,
right,
um, which was more towards like having research sort of like driven tooling
right,
for people using Mindplex Magazine and for the ASI for the whole ASI
right,
ecosystem for students to use and all. We were looking to provide our SEO data, provide a summary based in like a holographic state,
right.
this knowledge base graph of the
So
publication.
the
Yeah,
key, the key again, it's about approach, isn't it? I mean,
yeah,
the, the approach you take, we're concerned in is audit trail. So it's a bit like the ethical aspect of this, the AI ethics, yeah. So let's say you have a body of data, yeah, and the body of data is owned by the community, a community. Like in this case, we have our archives data, the ambassadors program data, is owned by the ambassadors program, yeah. So
true.
our approach is also taking that on. I think Vanny's done more work on this than me, but from a technical perspective, that means that we would have to have an audit trail of how we're using the data. Okay. So we'd have to say,
Yeah,
we're taking this data and also we have to inform the people who are recording the data to get their consent that the data is being used, that
yeah,
kind of thing. Yeah. Also, when we come to graph analysis, yeah, the same thing applies, yeah, for our data. We would say, okay, we're going to apply this logarithm to your data to
yeah,
detect patterns in the data. Yeah, right.
yeah.
Now, do you agree with the patterns that we are applying to the data? That's what we would have to say as a kind of consultation with the community to get consent for that. Yeah. Once you had that consent, you then would graph the data. Yeah. And then you would take that graph and then you could incorporate it within a knowledge base. Now, other use cases, you wouldn't necessarily have to do that. Like say, if you're doing research on historical research, for example, and you've got no one to consult there, you've just got a lot of data that you can use. So that's another aspect that we're looking at is what if your data requires you to go through an AI ethical workflow? Yeah. So that kind of thing. So have you considered that
Yeah,
or
we did had a plan to do the audit trials and all.
yeah,
So we were looking to do it on Cardano. We had a better chain upon Cardano
right, yeah,
and doing it with their own DIDs. There's a DID.
yeah,
There are a bunch of DIDs upon Cardano, but we were looking to use one of them. Yeah,
yeah,
and we're gonna do something on chain on contract to give us a consent about it. Yeah,
right,
so that was the whole plan.
yeah,
But
yeah.
yeah,
Yeah, I mean you can take it a lot further. Like I did a test where, for example, let's say you use the Cardano API and you got data from the blockchain, you could create a graph out of that. Yeah. And as you say, but then you could then make it specific to specific wallets. But again, it's about particular use cases. Um, the end result for Meta would be, again, I'm right at the beginning of my learning curve with atom space, but atom space is based it's kind of similar to Prolog. So it's a kind of list. So something I could learn. But again, when we got to that stage, I still would be concerned with consent. So it's a bit like if you're building a knowledge base, what interests me is
Yeah.
does the community know what's happening? Does the community and there's a few things there. One is consenting to using data. That's one thing.
Yeah.
Another thing is understanding. That's a real challenge. Yeah. So does the community understand the query? Yeah,
Yeah.
that's really interesting as well
S-
because and then yeah, go on.
Yeah, so the whole purpose of Mindflex, if we get into the old docs we made, the whole purpose of Mindflex was more about making reliable data.
Right.
Uh, yeah, so which can be fit into the Meta Hyper itself. So
Okay.
that's the whole objective in the end. So yeah,
Yeah. I mean,
this ambassador program data is gonna feed in just there. It's in
yeah.
the end from there raised too. So yeah,
Essentially, what we're
pretty good.
doing, again, with a different approach, what we're doing is socializing data, we're not just assuming that the data is there to be used. The data comes from somewhere, okay, and it's particularly data that relates to communities, and that means that its meaning is entrenched within those communities. If you just take that data and analyze it yourself, for example, without consultation, you will only get a one-dimensional view of that data. You only get a partial view of that data. So that's why the approach we're taking. Are there any other questions apart from that? Sorry, I want to sort of spread it out a bit, maybe. Or anything, any concept that people would like me to explain or any advice?
Yeah, thanks a lot, Stephen. I got in late a bit,
Yeah,
so
yeah,
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 but I've always shown a great interest knowing more about knowledge graph. Yeah,
yeah.
but I think from your expertise, probably if you can suggest some book or some learning material from the foundational side that some of us can get involved as in to know more.
Right.
Yeah, I think that's my question.
Okay. Well, we are going to try and work on some educational material ourselves, but that's going to take some time coming. If you want a quick start, one way would be looking at Neo4j. There is a free, I'll try and get the website for that, honestly. There is a free tier for that.
Okay.
Let me just try and find the website and paste it in chat. Okay, it's this one. Okay, and this will allow you the way that Neo4j works. It's all you can. It has you can just create a free account on there, and then you can take any data that you have. Let's say you have a spreadsheet, yeah, of data, yeah, like it could be anything that you have, and then you can take that CSV file and import it directly into Neo4j, and it creates an instance for you, and then you can. I think it allows you to run sample queries on that as well. Actually, let me just try and see if I can log into that. Let's see, start building.
Okay.
Um, I might have an account already, but it's oh, let's see. Right, I'll try and share my screen again. Sorry. The okay, well, people can see this. So if you logged into Neo4j, it's actually a bit slow for me at the moment, but that's what this would look like if people can see this. Um, Unfortunately, I'm getting the hourglass on it. But what it would, it's a bit slow at the moment, unfortunately. Oh, here we go. Okay. Um, so it allows you, it kind of holds you by your hand, as it were. Yeah. So you would log in. This is what it would look like on the initial login, and then it would come up directly with this pop up which say learn the basics. Yeah. So it can lead you through a self learning to sort of guide you into interactive guides. So, for example, here, manage your organization, that kind of thing. And it's based on a virtual machine where you create an instance and then you import data, but also it will tell you how to run queries on that data. So there you go. So you would create an instance here. Oh, there's a free tier. So you'd use the free tier. And then it gives you a password and so on. I won't do it because I'm not going to use that. But you can play around with this and it gives you some nice ways to experiment with graphs. Yeah.
Okay, sure. Okay.
Yeah, yeah.
Thank you.
Um,
Yeah. Okay, thanks a lot.
yeah, okay. I'll try and think of we're always trying to think of ways of how to create educational materials. So
Okay.
one thing we could start with actually is what kind of information do we want from the data? Yeah. So that's another thing. Appreciate people's input on. Um, the other thing that we will probably want to do once we've done some graph analysis is to feed that back to the community. So again, that could be a good learning exercise. Yeah. So, but it's something we haven't done yet. But let's say I do analysis on all the data from the archive for 2025, and we detect some patterns. Like, let's say we detect that a work group is often an intermediary between two other work groups, let's say. Now, we wouldn't just say, well, that's true. We would then feed that back to the community and to ask them the meaning of those patterns. So that's another thing we need to try and work out how to do that. Um, so again, I suppose that could be a kind of pro forma, maybe, or even an interactive session with people. So again, it's how you approach that as well. Fanny, yeah.
Yeah, I think just briefly to say that, while a pro forma or a form approach might be good, I do think that in any kind of exercise in understanding the connections in a community like ours, you get the best out of it with a meeting that people are prepared to
Mm,
contribute to, because sometimes you look at these graphs, you don't see things till you really talk it through. So we're kind of hoping that, towards the end of next quarter, we'll be able to run that kind of session. And, I don't know if Think Tank would want us to hop in and do it here or whether
yeah,
we do it somewhere else. But, really delving into what are we seeing from the inputs of this or that graph, and what does it really mean?
yeah.
And, is it how we understand our community, or is it seeing something that we don't think makes sense? Or is it revealing something that we just didn't see?
Yeah, absolutely. And we could do a session. There's a few approaches. One, we could focus on particular entities, for example. And by entities, I mean a node, like, for example, a work group, a person, another one, or a tag. Let's take those, okay? So let's say we take it as work groups. We could create sessions with different work groups themselves, maybe, or come to the sandbox and say, today we're looking at, say, governance work group. We're looking at the patterns in the data of governance work group. And I know that governance work group is actually, I mentioned that because it takes up about, I don't know, 14% of the data. It's quite a big community in terms of data. But what does that mean? Does it mean that it just generates a lot of data? Does it mean that a lot of people go to it? Does it mean it has a lot of influence? It may not mean any of those things. It may mean some of those things. Fanny.
Yeah, I mean, that's interesting because it hasn't always been this way with governance, as we know. And if we look at, if we graphed the whole of the archives corpus, I think we'd see something different. People who are newer might not realize that back in the day, governance used to meet once a week, if that. And we were always sitting there going, why don't people come? It's just because governance just isn't sexy. Why don't they love it? And now, because it meets twice a week and it's one of the few
Mm,
work groups that is kind of, like this one actually, that is having
mm,
ongoing meetings, people go to it and
mm.
people are getting involved. If we'd known that 2 years ago, it might have
Yeah,
been different. But what I suppose I was driving at is that in terms of analyzing influence, maybe just meeting often, which generates a lot of data and a lot of meeting summaries, is not the sum total of it. Maybe there's things around weight.
yeah,
Say, like, for instance, I don't know, I don't want to pre-identify what the data will show us, but I do think that often a treasury meeting, they might not be that often, but they carry a lot of weight and they have quite a lot of
yeah,
effect on the
yeah.
system. So yeah, it's interesting how things are weighted.
It's a really interesting point, and there's nothing I'd like to clarify here. You know, let's say we did some analysis of, say, treasury or something and governance, and we found from the graph data that, let's say, governance has 13% of the data. So, from a data perspective, it is a big community. It's very influential from purely a data perspective. But from if you consult with people, the meaning of it will come out. And so, as you say, Vanny, you may add a weight to that. You may say, well, the weight for this is what is this because of this. So, for example, let's say Treasury meets, for sake of argument, say a work group meets once a month, and another work group meets every week. Which is more influential? Well, it depends on the weighting of each of those. So a monthly meeting might be more influential or or more have more impact than a weekly meeting potentially. But another example is with people. I'll give myself an example here because I know that people nodes. You'll get people who will attend a lot of different meetings. So they will come up if you did analysis of communities of people, the person who attends the most meetings would have the most connections to meetings. So on the face of it, they would have the most influence on the face of it. But that person may not do anything at the meeting. They may just turn up, you know. Whereas another person may just go to one. There's I think of maybe someone like Andre or myself who only goes to one or two meetings or a month, let's say. Um, and I would be in from a data perspective, I would be have very little influence. But only if you add weighting to that would you add different meaning to it. Sorry, Vanny, you were going to say something.
No, I was just going to point out that we're past the hour. We don't have to stop because
Okay.
onboarding isn't meeting today. But I was also just going to say, did you say anything about structured and unstructured data? I
Oh
had to
yeah,
pop
yeah.
out for a minute and I
I don't
didn't.
I don't want to sort of blow people's minds a bit. Yeah. Yeah,
I mean,
yeah,
just
so
in the context of what we were saying, I was
okay.
just thinking that as people know, you often link a document or some other thing in a meeting summary. And those are part of the archives due
Yeah,
to the tooling that Andre has built to use Google's APIs to link it into the archives.
yeah,
Database.
yeah,
So that is often, a document is often quite unstructured data.
yeah,
And also some of our meeting summaries, they have that kind of meeting narrative field, which is very
yeah,
unstructured. All this will feed into the redesign we're planning of the summary tool, because often graphs work in a slightly different way and
yeah,
maybe a clearer way
yeah.
with structured data. But yeah, over to
Yeah,
you on that, Stephen.
yeah. Well, again, anyone who's got expertise in this is willing to help me on this, but I do have plans for this. And okay, let's take a step back. Okay, everything I've talked about today in terms of data is structured data. Okay, so the archive, the data that's dumped from the archive in a JSON format has a hierarchical structure, which is fixed. So it means it when we approach it, we are approaching it in a structured way. So the graphs will also have inherit that structure as well. However, we also capture different, as Vanny points out, we capture different kinds of data, like for example, attached documents and things like that. Now, when we've finished, well, when we can focus on unstructured data separately. And the reason why we would focus on that separately is because you'd use a different approach. I've done some basic research on this already, but again, if someone would like to help or I'm only one person, so but the way you would do it basically, you would create a reference point using your structured data, and then you would identify which structured data has unstructured data in it. For example, let's say your structured data is your data about a work group, okay, a work group meeting, sorry. And in that work group meeting, there is a link to a document, or there is a field with some free form text, let's say. You would iterate between that and extract out all the unstructured data, but you would still index it as where it comes from. So let's say all the free form text or all the documents that say that governance has produced, for sake of argument. Okay, then you would take that data and you would apply methods. There's a Python library called node to vec. And what it was, you would vectorize that you would take a more approach similar to creating a generative model. So you would vectorize it. You'd be looking for semantic patterns in the data. And once you've got those semantic patterns, you can then graph them. You can graph them. But it would create very different kinds of graphs and very different kinds of data. And it would be much more about, well, it'd be much more about semantic analysis rather than well, it's graph analysis, rather than um, statistic, purely statistical analysis. That's mine. Is that clear, Vanny? I'm not sure.
Yeah, I think so. Yeah, yeah.
Yeah,
I think until we do it, we won't really
yeah,
see how different it is, right?
yeah. And I need to, again, it's what people want to see and where's people's focus wants to be, you know. I probably could do a proof of concept, like take I've been meaning to do this, but again, it's a question of time, is to take some unstructured data like a document or I don't know, maybe a report or something, or a set of documents, and see what would happen if we applied a vectorization to it and did semantic analysis and converted that to a graph. But again, it's a question of priorities. But I mean, maybe it is a priority. I'm not sure. Maybe it should be a priority. I'm not sure. I mean, it is quite interesting because you're looking for meaning. You're looking for semantic meaning predominantly. Okay, should we wrap it up?
Yeah, I think.
Yeah.
I think Vas, you wanted to say
Yeah,
something else. I see your mic is open.
yeah, I'm just gonna show you guys this. I've started playing with the game. This is sort of like a thing. I think this UI is really good. That's why we were taking inspiration from this UI and Mindflex thingy I was talking about. So yeah, if we can get to this level of sentiment, yeah, Gulema, you have something to speak about.
Yeah,
Yeah, Vasu.
again, I agree, I agree. But again, it's going to be, you graph something and you've identified sentiment. Okay.
Yeah,
Can you codify that Vasu? Okay, that's what I mean.
yeah,
So it
yeah.
means
I
oh,
can.
it's one thing identifying patterns, it's then verifying those patterns. Sorry,
Yep.
Guillermo. So,
Yeah, so thank you guys for putting this one together. Was really looking forward to it, Stephen. So great stuff. We have been, we have been discussing and working with Vani on the governance dashboard, and definitely next step on the roadmap is how we integrate the power of the knowledge graphs. Definitely open source is the way to go. what we're building is going to have that fundamental. So yeah, probably looking forward to get into a call, schedule a call specific on how we can, because also we're going to be training assistant with all the work that you guys have been doing, archive and all that. So we need to team up on that. And also, I don't have the link, but I share it with Vani, I don't know, 2 months ago. There's also some tooling being built by the foundation in collaboration with True AI or something. I don't know,
Uh,
somebody
um,
else.
yes, the graph or something. I read that. Yeah, something
Yeah,
like.
there's already something that
Yeah, there's something
the
about it.
beta, the beta is online, and it's our tools, and it really look alike the UI, UX, the whole outcome like the one you are sharing, Vasu.
Yeah, yeah,
And
yeah,
I think it's open source. I think the limited, I don't
yeah.
know if it was 15 or 30 megabytes. You can drop
Yeah, let me just
PDF and the
check my
thing will
link then.
work.
Yeah, let me just
It
check
will
my link
work.
and share it there.
Yeah, it will work on an easy UX basis of dropping a PDF and the thing will
Yeah.
extract the info.
This is
So
Quello, isn't it?
Yeah.
yeah, I think, oh, that's the right one. Yeah,
Yeah.
definitely. I don't know if the thing is still up.
Yeah, it is. I think yeah, there was some things that it wasn't doing quite as it was
Yeah.
supposed to. Let me drop the link. Hold on.
I mean, maybe if you're
Yeah,
also,
So,
so
if
that's a
people,
good one too, but definitely open source and how we can
yeah,
apply this knowledge that you have, Stephen, into
yeah.
our governance framework.
I have been vaguely aware that you've been, well, doing development there. I obviously can't keep up with everything, but I understand that you're creating a governance dashboard and that's collecting data that, and then you mentioned generative
mhm.
data, generative interpretation of that. And that is the sticky part, if I would say. I mean, my main concern is to ground the data, is to make sure, for example, there's no hallucinations, okay? There's no massive misinterpretation of the data, okay? So my use of generative data would only be to more like an interface, if you like. So you ask a question, it understands the question, but it doesn't color the response, or it colors the response at a minimum, you know. So that's the key is with any data set you're collecting, is that, and that's why I'm taking the graph approach. Because you're not just you're modeling how you expect that how you want the data to be interpreted before you apply a generative model to it. So, and this isn't necessarily obvious because it's like trial and error as well. So I'm not saying there's not one answer. The best way is to take a data set and experiment with it. But then also there's, particularly if you're building something like maybe a governance dashboard, a dashboard that's been used by a big community, let's say, or lots of different people, then it becomes very important to apply AI ethical standards to it, which means that people understand, well, have an understanding of what the data they're putting and what how the answers are coming out, even at a very minimal level. So that's it. I'm not really on the SNet tool side. I suppose what I've been focusing on, particularly from advice from Peter, was on the meta atom space uh, uh, direction. So I'm not really
Yeah,
because they are that's the core
yeah,
paradigm, yeah. So now atom space. I mean, I've only just scratched the surface of this, but to me, it's just a slightly different way of creating graphs. But it's much more. It can. I know atom space can do a lot more than that, yeah. But it can also
yeah,
you can also use it to create graph. Now, it's not very practical for graph analysis because you'd have to basically write a community algorithm from scratch. So a possible workflow is that you would take some data, let's say, you do some graph analysis using one of the tools that we've shown today. Could be the tool that you showed, Vessi, or Neo4j or Gphy. It doesn't really matter. Okay, but the point is that you're going to create identify clusters or patterns, and then you reformat the data so the data goes back into your source, or it adds an appendage to the source, so it enriches the data. Then you can convert it to something like meta, yeah, or or if you like, well, that's one approach. That's the SNet approach, let's say. Or you could take the data and then put it, vectorize it. So you would create a generative model, but the generative model will be constrained, have very constrained prompts. So
I think one approach there will be just taking data, just taking the natural language data and feeding into the ASR1 LLM. Yeah, we can come out with
yeah, I
some
mean,
things for the decision making and all for the
yeah,
analysis too. But yeah, but yeah, I won't consider this high prawn as because things been changing to be honest.
yeah,
But there's been big delay for
yeah,
the
yeah,
high prawn is yet to be done and all. But yeah, I think using ASR LLM, one LLM, which is ready available
yeah.
and it's pretty easy. I
I mean,
think we can
yeah.
do better testing upon it,
I mean,
which is much more easier approach.
another reason why I
Yeah,
focused on meta and atom space, I looked at the whole range of things. It has a
yeah,
Python, it has a Python API, yeah. So it means I can write something quite open source. I can write a Python script. It becomes easy to document it. It's clear to see
yeah,
what's happening. Yeah. So I probably would take that approach. And also
yeah,
it's been around a long time, as you say, but
yeah,
it's also changed a lot, but it's the one thing that has, relatively speaking, stayed the same, if you like, atom space and matter.
yeah.
Yeah.
But is the API key open? I don't think so.
No,
It's open
the
for access.
I mean
Yeah,
not not it's a library. It's encapsulated in a Python
yeah,
library. That's what I mean. So that's what I did when I wrote. God, I'm just trying to see. Yeah, Hyperion Meta has a Python API. Yeah. So
yeah,
what you would do, you can get data into it and get it manipulated in terms of the atom space paradigm, okay, which is similar, has similarities with graphs. It has its own graph functionality, but it handles it with different names and things.
yeah,
And also it does, as I say, it does a lot more than that, I know.
yeah. Uh, yeah, I think I was still stuck upon the second approach I said, like just using natural language just for the sentiment and analysis and just for the basic
Right,
applications of it.
right.
And then later going upon the graphical things we can do.
Yeah.
Yeah, it's a really
Again,
big idea.
yeah, again,
Yeah,
there's a lot packed into that. Let's say you're doing sentiment
yeah,
analysis using
yeah,
semantic analysis. Okay, so again, you're
yeah,
going to get very different results from that than using, because
yeah,
that's unstructured data. Yeah.
yeah,
So
yeah, true.
that's, if you take structured data, you're going to get very different quantification of sentiment. Yeah. So I know there's different methods. If you look at I can't remember the library. There's a Python library called Vector. Sorry, I can't something. There's a Python library that allows you to do sentiment analysis, but it explains how different approaches to it. But again, it depends on how the data is being vectorized. So as you say,
Yeah,
if it's going to be free text, then you're going to get very, you're going to have to decide how you want to interpret it semantically, aren't you? So yeah, like for example, does the word um, um, agree mean this or something like that? So you'd have to,
yeah, true.
you see what I mean? So that's what I mean. What another thing that interests me, and I mentioned it, well, when Vanny was bringing up unstructured data, is that I think it's a really important distinction. So let's say you have some structured data, and if you regard that as a kind of reference point, yeah. So you say, okay, I know that there's this many work groups. I know they met at this particular time. I know that these people went there. I know that they decided this and they wrote down that kind of thing. Those are facts. They're structured facts,
Yeah,
and that's a really useful way to ground unstructured data. Yeah. So I always think I know. I mean, maybe I'm wrong, but when I'm thinking of it, particularly in the context of a community, is to try and ground unstructured data with some structured data, maybe. I'm not sure.
Yeah,
Yeah,
but I've
oh,
sent, yeah, Vanigo.
no, sorry, I was just following on from that to think in a governance context, what is structured and unstructured data have we got? To an extent, past objections from previous consent rounds are structured data, and so are whatever consents we get in this round. But then all the meeting summaries and all the linked documents and all the narrative, meeting narrative fields are unstructured
Mm,
data that support that and are kind of, as Stephen said, given context and given structure
mm.
by that structured
That's
data.
right. Let's say your structured data tells you that this work group didn't like this, didn't decided not to do something, let's say, okay, or decided to do something or whatever. And all the structured data tells you is yay or nay. It just tells you, yes, we decided, no, we didn't decide that, that kind of thing. It might give a reason, but that reason, again, um, there will be a structured interpretation of that reason and an unstructured interpretation of that reason. And as you say, Vanny, if you had some documentation associated with that, it would give you more nuance about that decision potentially. So let's say you attach to that structured data a whole lot of unstructured data, which would say it could be a transcript of a meeting, it could be a conversation, it could be a document, it could be, but and then you do semantic analysis on that. Again, it depends. It's very important how you do that semantic analysis, and then you can cross-reference that with the structured data. Maybe it'll tell you something different. Maybe it'll tell you, um, you know, sorry.
I know time's ticking, but this has just occurred to me as a question. How do we work with data that is ostensibly structured? In other words, we've got quite tight fields for what it is, but what people put in that field doesn't really correlate. I'm thinking about the consent process in quarters gone by, when we'd have a form with a field going, "What is your objection?" And then another field going, "What is the harm that will be done?" And another one saying, "What would need to change to get your consent?" And people don't necessarily put their objections in that structured way. Um, so do you know what I mean? It's like it looks like it's structured, but we've had times when it's been like a two-page rant just going into that field, and where it's not 100% clear what their
Yeah.
objection is. So how would a graph work with what looks like structured data but isn't?
Well, I'm glad there's another thing here is that it's not to get too focused on graphs necessarily. A first approach I would look at the data, let's say, okay. So let's say you got some decisions or something from people, yeah, and you gave them some certain options to respond, yeah, but some of the responses are contradictory, yeah, let's say. That doesn't need a graph to identify that. You can actually identify that using just a data analysis. So again, there's another question here about when you should use a graph. And again, it's something that I've been thinking about because I think a graph is more about modeling knowledge potentially rather than oh, it can be used for statistical analysis, but I would say it's indicative. It's not definitive. Yeah, it shows you maybe where the direction of things might be going in, but it won't necessarily give you a definitive answer. So whereas if you just did basically a straightforward traditional data analysis on contradictory fields, like you would expect this here, but you don't get that here, then that would show as contradictions, I think, maybe. But so again, it's not necessarily straightforward. Or another way, I think maybe there probably are ways to graph contradictions as well, potentially as well. But again, we can't do everything all at once. So I suppose from a pragmatic perspective, and this is like also building on what you're saying, William, about a dashboard, a governance dashboard, or any dashboard, is trying to think of discrete steps to take. So the next step I'm going to try and take is to try and do graph analysis in discrete chunks. So you say, I've done this analysis in this way, and then to feed that back to people. Maybe something like the Sandbox meeting. Yeah. So that may be really frustrating. It may take us a lot of time, but it'd be a lot better because it means you're bringing on the community, and that's really my main objective there. So, okay, should we wrap it up or
Yeah. Thanks, Steven.
yeah,
Thanks, Valen. Thanks, guys, for being here.
no,
Thanks for your time.
Yeah,
thanks for having us. Thanks.
I'm just gonna share one document you guys can go through.
Okay,
Has been published by the FetchAI ASR1. It's a graphical and
okay,
visualization sort of like a thing through natural processing. So yeah.
okay. Thanks, Vassie. That's really helpful. Great. Okay,
Yeah, thanks.
cheerio. I'll hop off. I need to get some lunch. So yeah, I'll catch up with you, William, as well.
All right,
Cheerio.
man.